Hi, welcome to our proposal video. I'm Daniel and I'm accompanied by my partner Michael. We are together in Team Saverio Space. We are gonna explain about the solution of our proposal in short in this video. Okay? So for the start, I'd like to discuss about the high cost of satellite launch remains a major challenge in space exploration and industry development, especially for emerging space nations like Indonesia. Most rockets since the birth of satellite launching rockets are single-use, a really complex piece of engineering just thrown worthless like its trace. That's why, over the centuries, engineers have been figuring out how can we reuse it and finally came up with a space shuttle that turns out just lower the cost a bit because its inefficiency. So lately, company like SpaceX is trying to make up more complex. Created by the Falcon 9 rocket with reusable first stage that land profitably, which save up to it's around more than 40% reduction in launch cost. Is very cool, right? Which is quite a leap in rocket technology, and due to the success in Falcon 9, private companies now realize the efficiency of this and trying to make their own system using highly complex computer and control. Wow, we are a bit far from this other nation, but it turns out Indonesia is actually one of the first to reach space back in 1964, the midst of the space race. But now we are a bit left behind. Indonesia is actually a really ideal place for a space program. The country like the US and Russia, or back then the Soviet Union, is trying to launch as close to the equator as possible. My partner will explain why.
Hi, I'm Michael and I'm gonna explain why is Indonesia quite the ideal place for a space program. Now, I wanted to ask you, do you remember the sport hammer throw? Now, the science behind it is while we spin holding it, the ball will have momentum and will receive centrifugal force from the spin. But then, we stop and release the ball. All of that momentum energy is transferred to the ball as centrifugal force. Then, the ball flies off from all of that potential energy. Now imagine the athlete is Earth and the ball is the orbital rocket. A hammer throw athlete typically spins at approximately 2 to 3 rotations per second before throwing the ball. Now, Earth spins at 1040 miles per hour or 300 to 400 meters per second at the middle latitudes, which mean roughly at 1/86,164 rotation per second. And now, we launch a rocket from the equator with the maximum speed and we get a boost. For example, the Soyuz rocket can launch around 7 tons to low Earth orbit from Baikonur, Kazakhstan. But from Kourou, French Guiana, it can launch up to 10.8 tons to low Earth orbit. That's a 40% increase in the payload capacity because of the boost, and that's insane. Now, for the proposal, we propose of a 3-stage rocket powered by solid rocket. Why solid rocket? Because it's lighter and cheaper and easy to make. And we designed the first stage to be reusable to reduce costs and make it more sustainable. We have a detailed document on our submission. Now we are gonna show how a mission profile will go in a launch. Due to visual limitation, we are using Kerbal Space Program and Spaceflight Simulator as visualization. T-0. Liftoff. The first stage ignite, boosting the rocket fast and high into the atmosphere. After that, stage separation, before the second stage will coast for a bit. Reaction control thrusters will orient the vehicle into the correct course before second stage ignite, boosting the orbital trajectory into orbital speeds. For the second time, the second stage will coast until it reaches the highest point of the trajectory. Then, the fairing will be opened and the rocket will roll to stabilize it, and the final burn of the third stage will circularize the trajectory into a stable orbit. And the thruster will stop the roll, and finally the payload can be separated safely.